Today we'll be talking about more music, um, on how AI can be applied to music. So last course, if you remember, we were talking about, what's AI and in general, what are people talking about in AI? So that give you a sense why people are inventing different stuff in the more technical and computing side of AI. And today we will look into how these technology can be applied to music in some more concrete examples, but we won't get into details on how these models work, how these algorithms work. But in the future, we will start to pick up something so that you get a deeper understanding of how these AI tools work. So I guess the general mindset of this course is not to, bombarding you about all the, details, mathematical background of all the models, but I guess is to equip you with the right reasoning or right understanding of how these models might be working under the hood, so that these tools will just change over time because AI, especially Gen AI, technology just grow and evolve so fast. So, but if you look at the core technology, they sort of stay the same, just that the interfaces change over time. So I guess that's the biggest thing that you want to know, and keep in mind when you are using these tools, rather than just looking at their I don't know, news release. Those are usually just talking about random stuff that they want to just secure some seed funding or whatsoever. Again, any question on the syllabus? I just sent the homework one link. Homework one should be pretty chill. It's graded by graded by completion rather than correctness. So basically you will look at a bunch of images or painting or human faces and listen to some recordings of the president's voice and Drake's music and see if it's real or fake. And I guess the exercise is not to get the correct answer, is to sort of like examine yourself, to reflect what you're thinking when listening to or looking at these different images or content whatsoever on the internet or whatever source that you get it from, and to think about what's going on in this field, I guess. Any questions on this? It's on Grayscope, but all the images I can show you, I guess. This Grayscope doesn't allow me to do sound. We are living in a very visual centric world, so Grayscope only allows us to do images. Anyway, it's all here, and on Grayscope, I mean, I will see something not like in your from your side, but anyway, it's just sort of like a quiz, Canvas quiz, but it's posted on Grayscope. But don't worry, it's not graded by correctness. Any question? Nope. So I guess have fun. I some of it are part of it is kind of easy, especially some of the Pope images, it's easy to tell. But for human faces, if you don't know them, they might be someone out there somewhere. If they don't know them, it's very hard to judge. But anyway, not perfect scope for me. Cool. Well, I think we just quickly go over some of the slides, just recap what we've been talking about last week. So last week we were basically thinking about sort of philosophically and sort of technically and thinking about what's AI. And so AI, basically, there are like four ways to define it, but basically there are thinking versus acting, and whether it has to be like human or it just need to behave um, like intelligence. Um, so, talking about, whether we want it to be thinking or acting, the most famous case is Turing test. This still has been sort of considered the golden standard of how to test the limit of an AI. But, the setup is pretty constrained that you can only communicate with, either the AI system or the actual human. Through some constrained or compressed channel of communications, usually just natural language or text-based. And you want to see whether they are AI. But, think about music, think about, improvisational agent, that's impossible. But, there are different forms of Turing test. But still, this is bring us to the question of that, how do we tell if a system is intelligent or not? That is it acting like a human, meaning that it's intelligent, or it does need to have that ability to reason and think like human. So that also have the same idea in music. So, all these models, they somehow generate some music, and you might think about, does it really know about music? But if it doesn't know about pitch, it doesn't know about scale, doesn't know about chords, how does it generate something? So, that's sort of the thinking, and maybe we couldn't actually reach into a consensus of how this is defined. And Turing test, which is an AI, which is a human, that's the interrogator want to see. And if you cannot tell, that's sort of past the Turing test. So, it's just reading questions. And, I love this. We always ask robot or AI, what can you do? Can you do it? Can you do that? But, think about us. We're not perfect in everything, but sort of like look at ChatGPT. You might be specializing one direction, but when you're going out of your expertise, then there's a very clear threshold that, ChatGPT might know something, basically basic stuff about a field much better than you. Cool. And so regarding that, we were talking about human versus AI, whether we want weak AI or strong AI. The weak AI is basically everything you've seen today that perform a single task, cannot learn from experience, cannot reason. But strong AI is, some of the AI community is trying to do, and OpenAI claim they are doing. But look at what OpenAI is doing, like ChatGPT. It doesn't have that human level intelligence yet in many fields. Some of the field it might, but most of the field it doesn't have that ability, and it doesn't have any self-aware consciousness, and it might solve multiple tasks, but it's not all like human. But it doesn't learn and plan. It sort of has a bit of personalization and interactability, but it doesn't learn in the long run, and it doesn't adapt. So let's bring us back. This is still one of my favorite definition of AI. It's just make computers do things at which at the moment people are better. So we look at these examples, but in music it's the same. In the past we talk about single line melody generation. We talk about melody plus code progression. And then nowadays, now we have Suno, now we have MusicLM, and you look at that and you might start thinking about, maybe this is not AI. Maybe we want something more. So things just keep going on. Cool. So that's sort of the recap of last week. Any question on that? Good. I guess the biggest question is, why should we care? Well, I guess, a lot of things going on in the AI side. And I think having the sort of like the right mindset of looking at these research to know, there are different perspective of AI and different pursuit of AI that sort of equip you with the ability to, look at all these different things, and you are like, why are people interested in it? artificial general intelligence. Why are people interested in that? People pursue different things in the field. I mean, every field people sort of like pursue different things. But that's sort of the mindset when you are navigating the field. And AI is very fast evolving. Well, so I guess I will start with talking about this field, music information research, which happened to be my field. And there's a bunch more AI for music happening outside of MIR, but MIR is sort of in the center of this field, because MIR is basically talking about music and how computing, how information can be applied. The technology we have in information, data science, in computer science that can be applied to music. And it just keep evolving. If you search MIR, people will be talking about, the old school, piano transcription, beat tracking, those tasks, but it just keep changing its definition. But I guess the best definition of it is just intelligent ways to analyze, retrieve, and create music. So we have an analysis, we have retrieval, we have creation. So this is sort of like the core three direction of how AI can be applied to music. And this is even before AI. This is just talking about how computing can be helpful. But these sort of give you a sense what the landscape is. And it's also, our course is sort of like divided into three different directions. So analysis basically means that you're getting some result, getting some music, audio data, and you want to see what's going on inside it. It could be, music analysis. It could be, core estimation, looking at, what are the function of the chords, and, look into your, you can do optical music recognition that, sort of like transcribe the sheet music from the original scan images. You can also do all sort of thing. But retrieval is focusing on how do you search from the huge database. And, from the music perspective, maybe it doesn't have much implication. How beneficial it is for us to understand music or to create new music interfaces. But this is one of the way that people interact with music. The public interact with music most frequently. That's through Spotify, through Apple Music, through YouTube Music, Amazon Music. That's the retrieval system and the music recommender system, and all sort of like similarity comparisons, so that have the user to find the music they want. Or sometimes music, pop music, usually 3 to 5 minutes, it just keep going on and going on. You don't have time to just sort of like in Google search that you search for certain music. Sometimes you want a playlist, sometimes you just shuffle it and just randomly exploring. So that is the retrieval side of MIR, and it's sort of like one big part of the industry, especially on the technical side, because it's a lot of profit coming from that. If you think about streaming service company, think about how Spotify works, you will be surprised. It's actually a bunch of, most needed technology is about, recommending music rather than understanding music. So it's fun to know about this over time. And lastly, about creation, all the Gen AI thing. We might see something later, but how can we help musicians or everyone, the public, to create music depends on their level of expertise. So that sort of like give you a sense what this is. And over the time, you will see that it's a very interdisciplinary field, that we have some ideas coming from EE, electrical engineering, that, MIR is actually started from EE plus music-ish field. If you look at the senior researchers in MIR or the early computer music, part of it are actually coming from the electrical engineering, because at that time we were looking at what are the audio, what are the signals, how can we represent audio, and we think about, how to analyze the frequency. And so all sort of like spectrum analysis, Fourier transform, spectrogram, all sort of things come from the signal processing field in EE. And so that's sort of the electrical engineering part of it. And we also have nowadays computer science part of it. Nowadays a lot of music is actually digitalized, and we are using a lot of AI system. And so that's the computer science part of it. But of course, there's the music in it. And so this is sort of like an interdisciplinary field that you sort of need some background in EE. But some of the researchers in this field don't know about what spectrogram is, but they're still doing great research. So, it's like an interdisciplinary field. And you might always question in yourself, are you prepared to do something? But I guess just go ahead and, as you might see in your final project, just go ahead and whenever you find something, you just try to figure it out. So that I think that's the way how you navigate this, because this field just stand across the boundary of these three overlapping fields. So, these are Adobe Firefly. Have anyone play with that? Cool. What do you use that for? Yeah. For fun?
My uncle is a professional artist.
Oh.
So he showed me how he was trying to use his abstract art as structures for generated.
Well, that's so cool, because you can provide the template sort of like, oh, that's so cool. Yeah. I never do it. I just like do text to image. But I think that's one way that it could be very interesting. You can provide in Adobe Firefly. I can show you guys what that is. But anyway, this is back in September 2023, and I find it very useful when I am designing the slides, because sometimes you just want a visual that you have no idea how to do it. Well, it suggests me this. I guess I would just go ahead. It's quite long. It doesn't make any. Oh, it just pop up the original one. Any crazy prompt?
Dog playing saxophone.
Okay. That's not art as far as I know. Did you see the suggestion? It's like in front of an old building. I saw the orange wall, right? Okay. Okay, we'll do it. Cool. It's pretty fast, I remember. And you can choose different shape. You can also choose by art versus photo. We can check it out later. And you can also upload your reference. Well, it's something. So if you're doing your slides, maybe you want to do this. We can check out something else. We can do square. And this is sort of like art, and so that's why the Milky Way doesn't look so real. Let's do photo.
Super realistic. Get rid of fantasy.
Fantasy? Sure. I think we can just get rid of everything here. Just do photo only. Anyway, you got some credit. Usually you won't use it all if you are not just like bombarding it. If you just casually, oh, it's pretty good, I guess. So yeah, it's kind of have some, I don't know, look like a meme. But anyway, so you can play with it. What I was talking about it. Yeah, anyway, these are like September 2023, that at that time is still beta, as you can see at the about a year. And now this is how I do it. using the similar prompt. I do some prompt engineering, but basically pretty much the same. And this is now, January 2025. And so you see that, part of it just improved, but, I don't know, which one do you like? Who likes this one? Nice. I like this one. Interesting, because yesterday I was giving a talk in MSU in their computing department, and sort of like every one of them choose this versus against this. And so actually I also like this because I feel like there's some interesting stylistic thing about AI. And if you ask me what's AI art, I would say it's not this, it's more like this, that, look at the background, there's some like weird reinvention of AI. Like, how does AI know about chips? It's sort of like, I don't know, it's sort of like doing surgery on chips. And, look at the code, how does it appear at the back of your Mac rather than in front of that? So, looking at these early, or say beta version of these generative AI system, that you can sort of like inspect about what AI is doing. And that's what I think is very interesting. And it's sort of, I feel like it's more creative in some sense. But anyway, that sort of give you a sense how things evolve so fast. And, whenever you want to see some crazy prompt, that you can just use Adobe Firefly for that. And there are other text to image generation system. There are Stable Diffusion, there are DALL-E 2. What else? Midjourney. There's a bunch. I think DaVinci is another one. Likely not DaVinci, but something relevant to DaVinci. But there are different image generation system. But I guess they give you a sense that, it's EE plus CS plus music in some sense. But it also extend beyond just music and audio. In the very strict definition, it also extends to films, sound design, stage design for theater, or sound design for theater. It could be live performance, so it's much challenging than we are just working on computer. How does it translate? How does it respond right away on theater? It can be applied in gaming, VR, and even you're playing RPG role play game that explore different maps. Could be responsive to where you are, or what your stage is, or potentially how you are playing the character. And to dance, to podcast, to show videos. These are some of the most needed applications nowadays. If you look at the job opening, lots of the tech jobs, AI music jobs are in the fields of, short videos companies. Because, in short videos, nowadays we have these like text to music, just like one single prompt. And if you look at how it could be applied to music industry, most likely it's like unknown how it could be applied, because you get a waveform basically, but how can you do with that? You have to apply stem extraction, so separation, you have to do enhancement, you have to whatsoever. But for short videos, sometimes you just want it to be quick, that you want to upload something in less than I don't know, 10 minutes, 30 minutes at most, and you want to maybe potentially live stream something. Then people want, sometimes if you don't have enough time, you want it to be sort of like match your theme or the goal of your video. So think about sometimes you think about why people want to use these tools, then you think about the other field. Like when you are doing slides, if you're not a visual artist, you might find it very hard to actually sort of like create some visual in your PowerPoint slides. To sort of like, if you ask a visual artist, then they might say, why you are using Adobe Firefly if you can just grab some elements in PowerPoint and then just build something out from that. I mean, you'll get better over time, but still really nice if you're just you're presenting tomorrow or like 30 minutes later, and you want a visual that you don't have. So that's sort of one of the way to think about why, people are interested in these like, one shot, quick, but not very high quality music generative system. Finally, and there are, music education, you can create personalized learning experience, but also think about not just AI, not just generative AI, think about AI in music education. Can you sort of like potentially help the learner to learn about an instrument playing more easily? And music therapy, this is still ongoing field, and using AI in music therapy is very high impact but potentially risky application. So people are moving very slow and cautiously. Cool. Any questions on these slides? Just give you a sense what this field is if you are wondering what it is like. Questions? Nope. Cool. I guess let's just move on. So we were talking about AI music in the early days. This is highly biased to AI music, on the generative side, but there are also the technology side, but that's, something that you will see and, intro to music technology. But in the early days, even back in 18th century, this is attributed to Mozart, but it's actually not created by Mozart, based on the study. But anyway, I still put him here. Anyway, this is like one of the very early sort of like, I wouldn't say AI, but sort of like intelligent or fake AI-ish generative system. There's a very nice GitHub page. This might be an interesting, I don't know, find a project idea. This is not a very crazy idea of a system, but basically what musical dice scam, as they go here, is that you have a bunch of composed melodies, and there are, how many there are? Things 8 by 10. There are two, so there are 160 melodies, and they are arranged, composed in a way that it sounds okay when you sort of like choose whatever row or column in that specific row. We can just play the demo. Okay. Anyway, I would just click randomize. So what it does is that it randomly choose one row across the 10, 12 measures. Just listen to it. Cool. So you can also do it another way, start with the same something else. Anyway, this just, it's this specific chord progression and, specific composition constraint that you sort of like challenge yourself how you can generate all sort of like different melodies that work well when you just select randomly in the row. So this sort of, like the early time of some sort of like AI music. If you search for the first AI music, usually it come up with this, but sometimes the next one. But I guess at that time, people are mostly, composers are mostly challenging themselves on this rather than they are actually interested in getting some AI generated music. But this is also another one that usually considered as the first computer composed music. This is the original composition that made by the computer is a string quartet. But actually, this is when they first invented the computer at the time. You see how big it is, look like a worship, but that's what it is. A computer is at Illinois at UIUC back then. But anyway, I think they invented they created that built that computer in 1950 something. And then soon after that, they realized we should just use it to generate some music. And so they wrote a program to generate this music. And it's just much rule-based rather than data-driven. But I guess we can listen to it, what it's like. How long ago? 70 years-ish, 65 years-ish ago. Sorry about that. Well, anyway, you get an idea. It's rule based and it's sort of like doesn't have that overlapping tunes. So just like switching in different instruments and pretty much less risky as a computer to generate music. Oops. And more recently, in 2007, this is before the AI era. So David Cope at where? USC, I believe. I forgot where he is actually, but anyway, this is sort of like before the AI era that people are looking into how rule-based system plus a little bit of early AI, what we can do to generate music. What might be the reference? Stop. Sure. Yeah, exactly. I mean, so if you look at listen to that album, it's just a bunch of different compositions, and each of them are sort of like you listen to it and you would just like realize that it just sounds like that, and that's exactly the goal of David Cope. He just wants to explore how you can sort of like fine tune or craft figured out a way so that your AI generative system to make it sounds like or compose music like the way that some style that people are more familiar with. So there's a tiny bit of like data-driven perspective of it. That's why it sounds more like the Moonlight Sonata. But at the same time, it's a lot of rule-based rules. So if you're interested, you can check out this very interesting article. It's an interview with David Cope. I like it because it's before all these, deep learning thing. So deep learning usually, if you think about when it starts, is in 2012. That's when we sort of like define the last recent AI not bubble, I guess AI, we called it AI winter when there's no one talking about AI. And so now it's like AI summer, I guess. But it's in 2012. So 2010 is when people are not, shocked by how AI might change the field. But this is before that. So it's interesting to see how David think about AI music before we sort of get a sense of what these data-driven deep learning approach could be used. But this is one of the quote that I find it very interesting, still applied today. People tell me when they don't hear soul in the music. But when they do that, I put out a page of notes and ask them to show me where the soul is. We like to think that what we hear is soul, but I think audience put themselves down a lot in that respect. The feeling that we get from listening to music or something we produce, it's not there in the notes. It comes from the emotional insight in each of us. The music is just a trigger. So this is a very interesting take on, sort of like when you listen to AI music or, in general, how you interact with music, that the emotional bounce, it's like, even it's AI, even it's not AI, there's still some interesting consciousness going on when you listen to music. So this is one of the recent paper on AI composer bias. It's very interesting to see that. So basically what they did in this study is to see whether human has a bias on AI generated music. So they just have a bunch of music. Some of them are generated by AI systems. Some of them are generated by human composers. But the idea is that they ask the listeners to rank their liking, basically. So at the axis is how you like it or how good the music is. But they also ask whether these music that you just listen to is generated by AI or not. So you can clearly see there's a negative correlation between them. So basically, people like oops, is this the wrong side? Yeah, people liking negative liking for more AI-ish music, and people like a higher score on liking for less AI music. So this is interesting. But how should we interpret these two figures? Just staring at it, what are your take on it? Any thoughts? Is it like, sure, go ahead.
People listen to like the electronic music version of it seems to be more accepted
Yeah,
as like the entire line is shifted up by
more likely to generate by AI. Yeah. But also just looking at one of these plots, what can you draw a conclusion from it? Is it like people don't like AI music, or is that people listen to music and whenever they think this music is not that good, then they attribute to that the reason is that it's generated by AI. So I guess the one of the interesting finding of this is that you see that correlation, but you don't know which one is the cause. Is it because it's AI generated, then you don't like it? Or is it because you don't like it and you attribute it to AI? But they didn't reveal what the actual composition is by human or not. But there are also other studies that just just test how human human musicians nowadays, we need to call it like human musician or AI musician, especially in the context of this course. But human musicians play in improvising with an agent. That agent is sort of like hidden behind a wall. And I think there's one study, I tried to find it, but I couldn't find it. But there's one study that's basically showing that when the study setting is like this, someone improvising with a system, that you have no idea. Somehow due to technical issue, they fool the participants. So making them believe that they are playing with an AI system that's in another room, but actually it's a human musicians in the other room that's improvising with the participant. So they just do this like A/B test when you tell them, yeah, this is an AI system or this is a human musician, and you will see how the participant respond differently. And even it's like human musician, they are like, yeah, it's lagging. I don't think understand what I'm doing. But if it's human compose musicians, then you just react differently because of the awareness of whether it's generated by AI or not. So I guess that's sort of the points that I want to make here is that um you know take aside on the performance and the emotional bonds that created by music. Some of the composition that it's just there. It's just part of the composition, and during that active listening process or the performing process that you start building connection with the music. But a lot of feeling and why we care about certain music is that we are thinking about how this music was made and how the musician is trying to convey. And that's something missing in AI music. But this is sort of a very interesting readings, for you if you're interested in to see, what people are thinking back in the days when, there are no deep learning models. Any additional thought on this? I find it very interesting. Cool. I guess at some point you will start to listen to some, short videos that might have some, music there that potentially generated by AI. And, it's happening in the visual art field. So nowadays, sometimes you see something, the first thought is like, is this AI or not? But, it might have some bias and some interesting thought. Cool. So I guess what we can do next is to give you the hint of what we will be talking about in this course. Next week we sort of like will dive deeper into what these models are, more technical things, so that to equip you with the correct way, or I don't know, a more deeper way rather than superficial understanding of these model. But this is something we can go over today without much of the details of how these models work. So think about ChatGPT. I bet I did a survey last week, right? I think everybody have played with ChatGPT, right? Cool. So yeah, I mean, let's start with ChatGPT. So you might heard of the term large language models. But anyway, sometimes you just see that LLMs that, LLM this, and people are talking a lot about LLMs. But basically, LLMs, you can now just pretend it is the models behind ChatGPT. So this is sort of like the interface with ChatGPT. I think I don't know when this is. I should have a note on that, but likely 2 years ago. But what's so cool about AI for music? Give me the brief answer, and you just stop talking about something. So what's going on behind this thing of ChatGPT is word by word generation. So these are the input, the question that you have. And what ChatGPT is doing is that just based on the first word AI, it starts to think about what's the first word to do, AI, and then think about what's next, and then music is cool, and blah, blah, blah. So under the hood, language models, the models behind ChatGPT is actually doing this word by word prediction game. So that's sort of the way that how we can look into this. So language models are the type of AI, not AI, types of models, machine learning models maybe, that predict the next word given the past sequence of words. So how it works in ChatGPT is it's not just Wikipedia, but it's easier for you to think about Wikipedia to give you a concrete sort of like imagination of realization of what those data would be like. So, most of the time you're asking something about a field or, then it's sort of like doing something like Wikipedia. So in Wikipedia, you might have a bunch of like a transformer is a blah, blah, blah. Transformer is a series of, what's that, science fiction action films. And here, something interesting when I'm making this slide, transformer is actually a gene. So, a transformer is, there could be a bunch of different words follow it. It could be electrical device. Here, it could be a deep learning model, as you will see in the future. It could be a family of genes. I have no idea what that is, but it's on Wikipedia. It's a fiction character. It's the movie. So the idea of what these language model is trying to do is to sort of like the animation, try to boost the probability that whenever you see this sequence of words that you want to generate, that, assign high probability to these words. And for other words, you want to assign lower probability to it. So it's likely not a type of food, potentially, but it's likely not a musical instrument. And so that's the way what language model is trying to do. But mathematically, what it's doing is this. It might look terrifying, but this is basically just saying that, given, so this is conditional probability, given all the previous words. Given all the previous words, what's the most likely next word? So what it's trying to do in these transformer model is just to see, these previous words and what are the probability of the next word. So this is just playing this like conditional probability thing. And if you are coding in Python, you will notice that there's no way, it is a probability. But the mathematical foundation of it is doing this conditional probability. But when you look at the code, it's just trying to, increase the likelihood, increase how likely you get the word that you like. So basically you want it to be more chance to get electrical, get more chance to get character, more chance to get gene, more chance to get model, but rather less, lower chance to get food and musical. So this is a very, very introductory way to start thinking about what these model might be working internally. So now, if we have this model, how can we generate some new new text? How can we do it like ChatGPT? So this is the very easiest way to think about it, even though nowadays we are using much advanced technique, but this is the simplest way to think about it. A transformer is then we just ask the model that we have here, what's the most likely next word? And we just grab whatever that's most likely. It could be deep. And then, now we ask the model, what's the next most probable word after a transformer is a deep? Then it's learning. And then you just go on and go on and go on to start talking about stuff. So that's basically what ChatGPT is doing. But if you think about it, it's less likely to be doing this sentence. This is a very low probability event because, likely a transformer is more likely to be an electrical device given the context, given the data we have on the internet. Well, this is a very introductory understanding of it, but any thought how ChatGPT stop talking about stuff? How does it know when to stop?
You add like punctuation mark as a word in the database, and therefore it can predict when a punctuation mark is.
Yep, that's one way, but ChatGPT also do it multiple sentence.
Oh, yeah.
So that could be one way. Punctuation is part of it, part of the generation. Any thought on it? Cool.
If the likelihood of the next word is low enough that it seems unlikely for there to be next word, like the most likely next word is low.
It's low. Yeah, that could be one reason, one way to do it. So you're saying that, potentially is like 100 words and all of them are 1% rather than what exactly you want to get. I think that's a good idea. But you will see the actual answer is actually very relevant to that.
Could you just limit the number of sentences and be like?
That's another way. I mean, that's sort of like the computational requirements. So actually, it's more like the way that it's more like the way that someone is talking in the chat. It's like you don't know what to say next. Yeah, stop talking. So yeah, that's the way how it works, but it's sort of relevant to that, so how ChatGPT is doing this is that we have this end of sentence or end of response token. So it's like a new word. So whenever we are doing the training, it's like, you have some training data that's like this input, and then it would generate this. There's actually a hidden ghost word here that says like end the sentence or end the conversation and the response. So when you are generating these text, if at the end you have no idea what is the most probable word to follow, there's that ghost vocabulary or ghost word that is like end of response that you can choose. So whenever it pick that, it will stop the response. So, these are some of the way that, these large language model, even you cannot see it, but that's how it's done internally. So it's not rather, you don't know what word to use next, but rather it's more sort of like, it's best that I stop here. So it's actually making that active decision to pick that ghost word, meaning that we want to stop the response. Cool. I guess get started to think more like how technically these could be done. But how does that work with music? Today we are just give you an example to give you the hint how ChatGPT could be relevant to some of the interesting AI music system. The key here is to see how we can design a machine readable music language. How can we represent music in a way that machines understand? So think about it. Machine definitely knows how to represent music. It could be just a bunch of, audio wave file. It could be sheet music. There's a bunch of different ways to think about, sheet music scans. But typically, we are not doing this because this is a task known as optical music recognition. So this is sort of one of the existing system. It's called music object detector. But anyway, this is sort of the real life situation when you want to actually do optical music recognition. And this is, I would say, a pretty well written sheet music. If you look at some of the, handwritten, sheet music, it's crazy. I mean, I don't even know what's going on. So that's give you the sense that this is in itself a very active field. But anyway, this is not an easy way to do it. And think about waveform, it's just a bunch of numbers. It doesn't necessarily translate to that. So I guess this is one of the example, very tiny notation that how this could be sort of like use a language-like representation to think about music. So ABC notation, as you can probably guess, what it's doing is basically just using A, B, C, D, E, F, G. And then, yeah, if you look at it, it's just starting here, C, comma, then that's the lower octave. And then, you have the A, B, C, D, E, F, G, A, B, C, D, E, F, G, A, B, C, D, E, F, G, and then you have the prime for upper octave. So anyway, you have A to capital G. I feel like I did something wrong. Oh, yeah, it's C, D, E, F, G, A, B. So this is the center octave. So AB is in the end. So they should start here. But anyway, this is the middle octave, and then you have C, D, E, F, G, A, B, and then you have C prime to B prime, and you have C comma to B comma for the lower octave. But basically, these are the notes. And you can also do accidentals. You can just do underscore, shorter underscore, equal sign, whatever, inverse V, upside down V, to do sharps. But anyway, this is like a very simple way to sort of like present music as if it's some vocabulary, some words. Any thought what this might be? No, I mean what this song is.
Oh.
Sure. Yep. I mean, yeah. Yeah. C, C, G, G, A, A, G. Anyway, so how you think about it, it's basically, this is a better view of it. This is the core notation, but this is how it is like. Actually, there are some, title, we will see the annotation. So basically, CCGG, and then you have the bar line, and then AAG2. So here we have G2, because it's sort of like double the duration. So the duration is determined here by the length L quarter. So that means that by default, everything is in quarter note. So CCGG O quarter notes, whenever you see 2, meaning that you have double the length. So now it becomes a half note. But anyway, that's one of the way that you can represent music in this very simple notation, which unfortunately is just melody only, but you can start generating something, or start to do something interesting with this representation. So we have meter, we have tempo, we have key, but these are not being used intensively in the case. So actually ChatGPT can do this in ABC notation, even though the song it generates is really bad. We can listen to this and then we can play with ChatGPT anyway. So I said something like write a cheer for folk song using ABC notation. I tried several different prompts. Everything comes quite similar, but anyway, sunshine on the middle. Let's listen to it. It's pretty bad, I would say. Oops. Anyway, interesting way to stop it, but it sort of do something. At least it repeats. Yeah, sure. You increase the resolution, so you change it into say 8th note. So that creates some chaos when you want to do something that more complex. In this song is basically everything is greater than quarter note. If you want to do it more fine grained, then your representation would be a lot more 8 for 16th. So usually people just do it at most at 8th or 16th notes. If you want to do it more fine grained, then everything would be 32, a large number for it. But that's how we do it. But anyway, if you're interested to see how bad that could be, do I need to log in? Oh. Well, anyway, we'll skip it. But you can just do something like this. So actually, I think OpenAI is not like they just magically learn this. They actually do something to enable this, even though the system is really bad. But I mean, somehow they just do it this way to sort of like show some interest in this of ChatGPT. So they actually train the model, fine-tune the model at the end to sort of like that it generate some ABC music. But anyway, this is one way to think about, how these, ChatGPT system might be able to generate music in some sense, but this is not ideal. And there's nothing close to what we are expecting AI to do. But ChatGPT is a text-based system. There's limited way that ChatGPT can do to do something that we are interested in. But that sort of give you the hint of what are some of these technology intertwined with the actual way how we generate music. And even though we are using some other models to specifically design for music, more expressiveness for music notation rather than ABC notation. It's like single line, single melody, monophonic, and it's like single instrument, doesn't have a lot of like complexity, no slur, no tie. But think about MIDI, think about music XML, think about other ways of representing or music notation, then that's the way that we imagine it to be. But even in the context of ChatGPT, just doing this next word prediction, that's sort of the way how we create these systems even today. So what it is doing is, even though there's this weird things here, but what it does is still, certainly, and then here is a cheerful folk song in ABC notation. And then it just start doing this like next word, next word, next word, next word prediction one at a time. So that's internally how this might be possible. And you will see in the future that this is sort of the underlying working mechanism of lots of the sheet music, symbolic music generator. But also even nowadays, if you look at some of the music LM, it's actually using something quite similar to this, just that you are representing music in a different way. Those vocabulary actually correspond to a certain audio chunk of music. And you'll see in the future. But this is sort of like the way how it is done. Doesn't work. Well, this is another interesting example of AI duet. This is, again, I tend to put a lot of like pre-AI, the early AI-ish thing here, so that you won't be, it's like the very early idea of This is a model that like the early exploration of Magenta on, using RNN, recurrent neural network, the simplest form of model, a deep learning model that can sort of like do the same thing as LLM, but nowadays you might heard about, transformer or diffusion model, GAN-VAE-ish thing in some of the news. But this is one of the early way that it do. But the same idea, predicting what's the most likely next word. Whatever that model is, still most of the model are doing that. So this is basically they train this model that just know what to do next, just predict what's the most likely next word or next pitch to follow by it. And they create this system that you can play
Hi,
with.
I'm Yutam. Hi, I'm
I don't think we should go over that, but you can play with it. So experiments with google.com/AI. It's very long, but anyway, you can find the slides on the course website. We can now play with it. I forgot where those are. Am I in the what? Oh yeah. Pretty bad, but let's restart it. I think I might did something wrong. So anyway, you can see it's not the like a polyphonic thing. And this is just like replicating the notes that I just played. And if you think about in the mathematical way, the last notes you play is most likely to be play again over the future of time. So this is sort of like a very tiny examples of what people have been doing in the past. It's just a model that just predict whichever pitch is the most likely next note. Anyway, we should go into some of the more interesting application of it. We are running out of time, but I think we can go over this. So this is Piano Genie. This is another example. This isn't, sort of like Gen AI, but it's sort of more, less like, just autonomous generating stuff, but more like you are getting some input to the model. Cool. So basically this is a very cool way, very cool application that you can play online. Oops, it's not this one. So you can actually play online. It's 1, 2, 3, 4, 5, 6, 7, 8. So this is like just a button control, but you sort of like want to play piano on this like just 8 notes. And what you want to do is that when you go from like 1 to 8, you still want that, rather than, that 1 should correspond to something lower and 8 should be something higher. And then when you do this, so basically what it wants to do is to sort of create a new interface of piano that you can sort of like just use 8 notes to sort of like control it, but you'd still get that intuitive rather than, relative, pitch when you're controlling this system. So if you're very interested, you just go play with it. It's pretty fun. I mean, as you might notice, it's very hard to get something like this. You need to play with it, say, I don't know, a day or ish, that you can actually create something interesting. Most of the time, it's just like you are sort of like adapting to this semi-Gen AI system, that it's more like you're adapting to it rather than they are adapting to you. But anyway, it's really cool to see it. But just to hint you about what it might look like under the hood. So what we get is just like this. This is the piano roll representation. Basically, you have time and the x-axis, and then you have pitch at the y-axis. So sometimes in GarageBand or Logic Pro, whatever DAW that you have, or you will see this. You have music MIDI files represented like this. MIDI file is MIDI file, but piano roll is just a way that people visualize the music. What it wants to do is, sort of like map this melody to that 8 button, so that you can sort of like use that 8 button to sort of like play this melody-ish. And, it's a machine learning system. You want to sort of learn that. So how did this is, in a high level, is that we want to sort of like train or figured out what these two things could be, like an encoder and a decoder. So the encoder is trying to sort of like map this complex, I mean, by no means complex, but for this particular interface, complex. Can we sort of like encode it into like these 8 buttons? And that in a way that we can sort of like decode that more accurately. You would definitely make some mistakes, but can we do it more accurately? So that's sort of the idea that what they want to do, and they sort of figured out some machine learning thing, all the details we will potentially talk about in the future. But that's the idea that you want it to be more intuitive. You see the appraisal here, and you want it to be sort of like a very smooth transition. And basically, the machine learning side of thing is that they have to design special loss functions, special regularization term. We will go over those in the future. But basically, this is the technical side. If you do nothing, if you just want to sort of like think about, this is sort of like compression. You have the waveform and you want to make it into MP3, you want to reduce the size. This is basically the same idea. You have like so many beats, bytes, or size that you can represent this music, but you want to compress it into only 8 buttons. If you don't do anything on the machine learning side, this is what you can get when you sort of like compress this into 8 nodes scenario. And there's nothing intuitive this here. If you look at the Pragio, the 3 Pragio, there's nothing like that here. Maybe here, but it's just like moving drastically rather than you see that, clear Pragio here. So that sort of give you the sense that what technology or these AI deep learning model can help in this particular example. It's interesting to see some of their actually, they sort of
like that is,
make it into this.
and it depends on how bright they are. Things are really bright. We know they're like a yellow and a green, and it's all a little hazy. It's pastel. It's not as. I mean, I think it can be effective, but I don't know if it can be, 20 colors.
Right.
You know what I mean?
So they basically collaborate with the Flaming Lips. And these fruits are actually connected to some sensors. And those sensors are, sort of acting like these buttons. And so, the size and the colors, certain the apple correspond to the lower notes, and the kiwi would be a higher note. So that's basically what they've done.
Because he's being more virtuosic, so it's more like the actual data.
And more interestingly, they actually bring it into like Google I/O in 2019, that they create this huge balloon that actually is doing.
The balloons in the crowd and the fruit bowl on stage are basically 2 sides of the same coin. They all feed into the same radio network. In other words, every time someone from the crowd interacts with one of our balloons, it creates music using the Piano Genie network.
And then at some point, the more that they play with it, the more the algorithm is going to start to be encouraged or go into another dimension. I think that's a great musical moment.
We've written a song especially for tonight's occasion.
At the end of the day, that's what these algorithms and all these things are doing. They're just sitting there helping you. And I want that. That's a new beginning.
You could definitely check it out and play with Piano Genie. I guess we can stop here. It's about time. Any questions? Cool. See you on Wednesday. We will talk more about some other interesting application.